This section is greater than, less than, kinds of questions. So how do you handle greater than, less? That's what's unique. You know, it's hard on a math test because all this stuff kind of looks alike, and especially if we're doing these more advanced things. You can get to the exam. When is our exam? Next week? The exam is next. No, it's 2 weeks from today, huh? 2 weeks from today on the 13th. 2 weeks from today. Monday after next, 13th. Anyway, you can get to the exam. It can all kind of look alike. And so let me help you. So how you're going to recognize this stuff greater than, less than. See, greater than, less than, you go, okay, what do I do? Step number one. Yeah, I'm not going to do it that way. I'm actually going to break away from the other way. Step one, change to equals and solve. Yeah, if you saw the other YouTube, that is a valid. If you learned that, great. If you're good at that, great. Feel free. I'm going to make it a little easier. I just decided to make it, that way it was more thorough. So if you saw the other one, great. So Zachary, you saw it that way?
I didn't get the note to not do it, so.
Okay, so that's great. I'm going to show it a little simpler this time. Okay, so change, this will be different. Change to equals and solve. And then step two, denominator alone equals 0 and solve. Step three, put the answers on the number line and check one region where for true or false. And okay, so never bracket next to denominator equals 0 answer. Okay, so there it is. I'll let you copy that down. Okay, so here we go. Let's dive in. Question number one. So this is what you'll see when you see on the exam 2 weeks from today. You see this kind of thing. You go, oh yeah, greater than, less than, got to do those 4 steps. So have those 4 steps right in your 3x5 card, hopefully, right? So you see this, you go, okay, got to do that whole thing. So here we go. First step is change to equals and solve. So let's change to equals. So step one, whoops. Step one, so change to equals and solve. Now, how do you solve that? You all are pros at solving those, right? How do we solve 2 parentheses equals 0?
Give them 0.
Yeah, each one can be 0, right? Because 2 things times to be 0, either one could be 0 to make them times and be 0, right? You know all about that. So the first one is 0, or the second one is. Notice I changed from greater than to equals. I'll come back with the greater than when I do the number line. But for now, I'm just making it equals. So each one equals 0. It's just going to be opposite sign, right? You know the drill. We've done this a bunch of times, right? Just jump it over. So we're going to get x is -3, x is -1. Let's go to step 2. Step 2, skip. No, we have no denominator. So steps 2 and 4, half the time, we'll skip because they're only for denominator problems, fraction problems. So half of the questions in this section will be fractions, and we'll have to do steps 2 and 4. But half of them won't be fractions, and so we don't have to do 2 and 4 because 2 and 4 have to do with denominators. We don't have any denominators. On to step 3 we go. Step 3. Now, what does step 3 say? This is the most important step by far. It says take a number line and take those 2 or however many answers you got this, got that, and put them on the number line. -3, -1. So I put them on the number line. That breaks the number line up into 3 different sections, doesn't it? Left, middle, right. 3 different sections. Okay. So now what are you supposed to do? What does it say for step 3? It says, put the answers on the number line, check one region for true or false. And it says a good idea, how about where x is 0? You don't have to, you can do it anywhere you want. But that's usually the easiest. So where is x equals 0 on this number line? Is it the left section? The middle section? You know what I mean? What kind of numbers are, if this is negative, then this must be -4, -5, -6, right? In between here, this must be, like right in the middle, this must be -2. It's right in the middle of -1, -3. Where's 0? Okay, here's 0, here's +1, and on go the rest of the positive numbers, huh? So, since 0 is the easiest number in all the world, that's the only reason I'm picking 0, just because it's easy. You can check anywhere you want. You're like an electrician checking for power. I finally figured out how to use my multimeter over spring break. That's one thing I did over spring breaks. I watched a YouTube video about how to use a multimeter, which is very simple, but I've never done it before. Where you stick the probes in, you find out where the power is and different stuff. Anyway, that's what we're doing. We're like an electrician checking for power. We're going to stick our probe in and find out if, and you can go to any one of these sections you want, and you're going to find out if there's truth there. Instead of power, it's truth. True or false in that section. So I like to just do the easiest thing I possibly can. So that's going to be going right here. I'm going to check x equals 0 with, I'm going to check for truth, like checking for power. Now, whenever we check anything in math, where do we go to check it? What version of the problem? Where do we check things? Always. Very first step, original problem, huh? Always, that'll never change. Whenever you're checking any problem in math, you're checking the original. So when I say check equals 0, I mean go back to the original. Before you changed it to equals, before you did anything else, original, of course. All right, so x plus 3, x plus 1, greater than 0. I'm going to plug in 0, plug in 0. What do you get? 3 times 1 is greater than 0. 3 times 1 is 3. 3 is greater, bigger than 0. Is that true? We're checking for truth. Is that true? Yeah, for sure. Yeah, 3 is bigger than 0. True. That means that whole region is truth. That whole region has power, so to speak. Now, here's the great benefit of this technique that'll save you time. They switch back and forth. The regions switch between true and false, back and forth. So if this right region is true, if this over here is true, what must the middle be? False. And what must the left be? Back to true. Yeah, it's always going to switch back and forth that way. True, false, true, or false, true, false. It's just going to switch back and forth. That's why you only need to find one region, then you know the others are the opposites. Now, that's not really true what I just told you. But it's true 99% of the time. I'll point out when it's not, and I'm probably not going to give you I'm sure I won't give you when it's not true on the test. If you go to higher math, go to pre-calc, I don't teach it this way. I make them do a deeper way because there is a 1% time when you can actually get 2 truths in a row or 2 falses in a row. It can happen, but it's very rare, and this will save us a ton of work. And so, but I just want to let you know the whole truth. Full disclosure, I'm not telling you the whole truth here. They don't have to go true, false, true, false. They do 99% of the time. If you go higher, if you're majoring in math or science, you'll see that later on there's a little more to the story. But this will save us a lot of effort. All right, and a lot of time. So now, great. Okay, we got the true, false, true thing. Well, what does that mean? Well, what are we always looking for in math? Where do you think, what sections do we want? The true ones or the false ones? True, of course. We're always looking for the truth in math. So that means this section and this section. The true sections must be the answer sections. No surprise. Greater than, less than questions, you always have whole regions of answers, not just like one number, the answer 7, or something. It's a whole region, because that's the very nature of greater than, less than, isn't it? There's several possibilities. If I said I have greater than 3 keys in my pocket, that doesn't mean I got to have 4. That means 4 or 5 or 6 or 7 and on you go, huh? The very nature of greater than, less than means whole regions of answers. Anytime in math you have a greater than, less than question in the beginning, you know in the end you're going to have regions of answers, not just individual numbers. Right? So our answer is those two regions. Now, how do you say those two regions? Remember how to do intervals? Remember an interval, a chunk of shading. Like we've got two chunks of shading there. A chunk of shading, you have to put the left edge and the right edge in parentheses. Do you remember that? That's how you say an interval. It's been a while. Like left edge and a comma in between, huh? Left edge, comma, right edge. So left edge, comma. What is the left edge of this first chunk of shading? What's his left edge?
Minus infinity.
Yeah, because the arrow says left forever. So how do you say that? Minus infinity. Exactly. Good. So minus infinity. And what's the right edge of the first chunk of shading? What's his right edge? Negative 3. That's where that boundary was, huh? Negative 3. So that first chunk of shading goes from negative infinity on the left to negative 3 on the right. All the numbers from negative 10 zillion, zillion's not really a number, but you know what I mean, from negative 10 trillion up to negative 3. All those would make the original equation true. And not only those, but numbers in the second region. Now, how do you say the second region? Same way. Left edge, comma, right edge. What's the left edge of the second chunk of shading? Negative 1. What's his right edge? Regular infinity. Huh. He goes from negative 1 to regular infinity. Now, how do you know whether you use parentheses or brackets? Do you remember that? So we don't worry about rule number 4. That has to do with denominators. We're not even dealing with that right now. Basically, if you have bars, then you got brackets. If you don't have bars, then you got parentheses. Remember that? Because the bracket means you're straight on that number. That's why the bracket has a straight back to it. Because it's equal, greater than, or less than, or equal to, right on the money. That's the bracket, right? Whereas the parentheses, they're just rounded. They're just around the number. They're just close to it. They're not right on it because they're just greater or less. They're not equal to. Remember that? Bars go with brackets. Okay, anyway, so we have parentheses for sure on this one because we didn't have a bar in the beginning. These are all parentheses. Do they want me to put a U or a comma between those? I honestly don't. Yes, they want you to stick a U for unite between those two, and that's our answer. But what are we saying then when we say that's the answer? We're saying any number from negative infinity up to negative 3, or any number from negative 1 to positive infinity, all the numbers in either one of those regions will make that thing true. Let's test it out. You don't have to. It's guaranteed to work. But I think I've noticed over the years it's helpful to students to see what we're really doing. Let pick a number that's in this range over here. What's a number in that zone? Negative 4, negative 5, negative 6, negative 10 million. How about I'll do negative 5, whatever. So if I plug, now x can only be one thing at a time, right? So if x is negative 5, he's negative 5 both locations. So we're saying that negative 5 or negative 6 or negative 4, any of those, is going to make it true. Does it? Negative 5 plus 3 times negative 5 plus 1 is greater than 0. What's negative 5 plus 3? Negative 2. What's negative 5 plus 1? Negative 4 is greater than 0. Negative 2 times negative 4? 8. They're multiplying. 2 times 4 is 8. Positive. 2 negatives multiplied to be positive. So positive 8 is greater than 0. Is that true? Yeah, look at that. It knew just what to do to make both those negative. How about numbers over here in the right section? What's something bigger than negative 1? 0, 1, 2, 3, 10, 15, 20, whatever. So let me plug 1 in. I'll go back to the equation here. What was it? X plus 3, x plus 1 greater. Plug in something like 10. Is that true? 10 plus 3, so that'd be 13 times 11 is greater. Yeah, 2 positives, of course it's greater than 0. See how it knew just what to do? It knew to go to the region where you got 2 negatives, because 2 negatives multiplied to be positive, or 2 positives, because either way it's going to be greater than 0. There it is. We just followed the logical truth, got the answers. That's what that's telling us. All the numbers that'll make that thing true. Everything that'll make that thing true. All right, questions? Here it is, number 2. Give it a go. So you see greater than, less than, 2 weeks from today. First step. make it equals. And then you're going to need to factor it with two parentheses, right, to solve it.
That range, that's when you find here about the true or false. We said about the answers, they become equal to 0, but not more than 0.
We'll get there. Let's see. So you see a factor first off equal to 0, right? We good. You changed to equals. See how I changed it to equals? That's step number 1. Everybody knows that? It's no longer greater or less. It's equals. I changed it on. So when I do the check, I'll go back to the original, of course. But for now, I've changed to equals. And then, it's just going to be -2 and -4. Is that okay if I just jump to that? -2 and -4. Step 2 we can skip. I go right to step 3 because this one's not a fraction, so I don't need steps 2 or 4. And then put on the number line. Now here's 0, -1, -2, -3, -4, -5, -6, 1, 2. A bunch of numbers. So where am I supposed to put my lines? At -4 and -2. So I let that break it into 3 sections, left, middle, right. It's going to be true, false, true, or false, true, false. I don't know which. I have to figure that out now. So that's the whole goal, because in the end we want the true section or sections. So it's all about, is it true? We know they switch back and forth. Is it true, false, true, or false, true, false? How do you know? You just check one of the regions. It really doesn't matter where. You can check any number you want. It doesn't matter at all. Check for power wherever you want. I'm just saying, hey, I'm going to do the easiest thing I can. The easiest number in all the world, 0, is right there. So I always go to wherever 0 is, unless the line goes through 0. I'll show you one of those in a minute. Anyway, check x equals 0. Now, whenever we check anything in math, we check the original, don't we? So grab the original. X squared plus 6x plus 8 greater than or equal to 0. Plug in 0, plug in 0. 0 squared plus 6 times 0 plus 8. That's 8 greater than or equal to 0. Is that true or is that false? Is 8 greater than 0? Yeah, true. This is a true. Middle must be false. Left must be true. Same kind of answer as last time. True section here. True section there. So how do we say our final answer? Give those intervals. Left edge, -infinity to -4. Now, we need, I'll do that in a minute. United with -2 to infinity. But we need some brackets here, don't we? Now, you never put a bracket next to an infinity because you can never be right on infinity, right? Even if you go to the Apple store for 5 hours and it feels like forever. Was it 4 hours, Kiana? 4.5. That would feel like forever to me, but it's really not. So there's never a bracket, but the numbers will get brackets, won't they? So I'll put a bracket at -4, and I'll put a bracket at -2. Still keep the parentheses at the infinities, but we're straight on the -4. We're straight on the -2, meaning we're including -4 itself. Will work. Will be part of our answer. Right on the money, -4, and right on the money, -2. Not just close to them, but we include them. There's our answer. We're done. We can check it. It's true. Questions I can answer.
So what was the difference from the last problem with the bracket thing?
So the last problem didn't, good question. We have an equals here.
Oh, okay.
So yes, if that was just greater than 0, then I would just put parentheses everywhere. Yeah, you only even try to put brackets anywhere if you have the bar bracket, BB, bar bracket. Because that's equals, that's straight on the number. Good question. We good on that? Other questions? All right, let's do that one. So I skipped 3, that's easy, same old. Try this one. So you have to do one more step of factoring here, right? Well, first step, change it to equals 0. Equals 0, and then do one more step of factoring. Right, difference of squares, x plus 6, x minus 6, remember that?
So we factor
Yeah, factor them individually. Exactly. Exactly right. That's step 1. It says change to equals and factor. Yeah, so remember it's x plus 6, x minus 6, and it's x plus 3, x minus 3, and you change the two equals. Remember that? Remember that difference of squares? It's called factoring, or I call it double-double, whatever. Like that. It's got to be plus and minus, because positive times negative makes negative.
We're going to have 4 answers.
And then so it's just going to be those 4 answers on the number line. Right? It's just going to be negative 6, positive 6, negative 3, positive. Just opposite, opposite, opposite. Okay, I just jumped to it like that, save some time. Go right to the number line. Step 3. So put those on the number line. Start here like negative 7, negative 6, negative 5. So, put your bar bracket things in there. So where do they go? Negative 6, positive 6, positive 3, negative 3. There we go. Look at that. We got a lot of sections, don't we? So put big lines there. I'd encourage you to put big lines through those because you're dividing. You want to see it clearly, dividing up the number line into those. How many sections? 5 sections. There's always one more section than there are cuts, right? You cut a stick once, it's 2 pieces. Cut it twice, it's 3. Right? There's always one more piece than there were cuts. Right? So we cut it 4 times, there's 5 pieces. So 5 pieces. So you just need to check one piece for true or false, and then you know it switches back and forth. And what's the easiest number in all the world?
0.
So go to 0 and check 0, which is right smack in the middle. So let's do that. Go right here. Check x equals 0. Whenever you check the first step. So grab the first step. You don't need the factored version. You don't need anything other than the first step. Plug in the 0. So that'll be minus 36 times minus 2 negatives. Positive, some number, I don't even care. Any positive number is greater than 0, isn't it? So is that true or false? That's a true section. So that is going to be true. We good to that there? Because 2 negatives multiply to be a positive number. So that's true, and then you just switch back and forth. So it's true, false, true, false, true. Switches back and forth. And we're looking for the truth. So we want this section in the middle, and the right section. So how do we say those sections? Well, the left one will be negative infinity to negative 6. It goes up to the line, huh? Negative 6. These are all parentheses, aren't there? There's no brackets here. How do we know there's no brackets?
There's no bar.
There's no bar. It's all, right? The original was greater than 0, not equal. So, united with, and then how do you say the middle? Negative 3 to 3. United with 7, or 6. That's 6, huh? That line's at 6. To infinity. That was the last true section. So here, I could write it's hard to read my answer, I know. Let me bring it up here. Minus infinity, minus 6. United.
So when you type your answer on Excel, you're going to have to put united?
Yeah, they have that on the template. They'll have a little U there. There we go. We good? All's well? Questions I can answer? About ready for the fraction ones?
Confusing.
What?
It just feels like, I don't know, weird just doing it, but I'm getting the right answer.
Okay.
I don't know.
It's very different. It's very different than
Yeah.
anything else we've done. Yeah, so remember, greater than, less than, very different. And you got to do the whole number line, true, false, true thing. Yeah. So I'm trying to key your memory with that differentness so it jumps out at you on the. All right, so here we are. It's greater than, less than. 2 weeks from today, you'll see it. You'll remember, oh yeah, you got to do the whole number line, true, false, true thing. Step number 1. What's step number 1? Change to equals and solve. So let's do that. Step 1. So I'm going to take this thing, change that to equals. I'm going to solve it. Now, how do you solve that thing with an equal sign? How do you? We've solved these kind of before. What do you do? Yeah, because when you got a fraction on one side and a whole number on the other, put this guy over 1 and diagonal, right? Cross multiply. We've done that a few times. You have fraction on one side, whole number on the other. Just put it over 1, make it look like a fraction. Diagonal, cross multiply. And so then that's 9 times 1 is 0 times x plus 6. 9 times 1? 9. 0 times anything? What's up with that? No answer from part 1. Step 1? Nothing. Nothing's coming from step 1. No answers out of step 1. 9 doesn't equal 0, and x has vanished on us. So there's no answers out of step 1. It's okay. We got a step 2 coming. Let's keep right on moving. Step 2. No, this is the first time we've done step 2 today, or ever. This step 2 anyway. What's step 2? Denominator alone. Just him equals 0. So grab the denominator. Say you alone. Now, why are we doing that? Well, because when the bottom's 0, that makes things undefined. Do you remember that? When the bottom of a fraction is 0, that's the big no-no in math. You can't ever let the bottom of a fraction be 0. You can't divide by 0. So we need to go for just that. So solve for x there. Just going to jump it over. -6. So now I'm going to go to step 3, the most important step with the number line. And the only answer, there's only one answer that's going to go on that number line. The one I got out of step 2, because I got nothing out of step 1. So step 3. The most important step, the number line step. So now on this step, here's here's 0, -1, -2, -3, -4, -5, -6. So here is -6. Here is 0. Here's numbers like -7, -8, -9, etc. So I'm putting a line, a marker, a break at -6 only. -6 only. So how many pieces am I looking at? The number line's in how many pieces? 2 pieces. We took the stick and we broke it only once. It's in 2 pieces. Okay, so it's either going to be true, false, or false, true. We just need to check either side. Doesn't matter. I'm going to go to the easiest number in the world, 0, and I'm going to check there. So right here where 0 is, I'm going to check x equals 0. So I'm going to take the original before any changes were made, 9 over x plus 6 greater than 0, and I'm going to plug in the 0 there. What do we get? 9 over 0 plus 6 is greater than 0. 9/6 is greater than 0. I don't really need to even know what 9 divided by 6 is. It's positive. Positive numbers are always greater than 0. If you're interested, it's positive 1.5. Is it greater than 0? Yes. We haven't had a false check yet, have we? Everything we've checked has been true. It comes out false about half the time, but it's been true every time. So this side is the true side, and the other side must be the false side. Are we ready to give the final answer? So here's the truth. We going to have any brackets? No, we didn't even have a bar, so no brackets at all. So the final answer then is just that one true chunk of shading. How do you say this chunk of shading? -6 to infinity, parentheses. Now, I don't even need to worry about step 4. Step 4 says that it says, what is it? How does step 4 begin? What are the first 2 words of step 4? Never put a bracket. So it's warning me about not putting a bracket. I'm not even tempted to put a bracket on this one. So don't even worry about it. The only time you're going to need to look at step 4 is if you were thinking of putting a bracket somewhere. It's cautioning you that it won't really go somewhere. So let's not even worry about it right now. I'm not even trying to put a bracket anywhere. I don't need a warning about not putting a bracket anywhere. We're good. That's our answer. -6 to infinity.
So you're telling me that if that has equals to, or
If it had the bar,
more than or equal
then
to,
I would think about it.
but
Yeah,
we do-
we'll get to one. Let's wait till we're actually there. We good on this one? Does that make sense? So we have that extra step 2, denominator 0. Let's take a look. So let's go through the steps. So step number 1, what does it say? What does step number 1? Change to equals, right? And solve. So I change this to equals and I solve. How do you solve when you have a fraction equal to a whole number? Put it over 1 and go diagonal, diagonal. Do you see what I mean by that? I mean 7 next to 1 and 2 next to x minus 1. Is that good for the diagonal, diagonal? And then 7 times 1 is 7. Distribute 2x minus 2. X is saying, I want to be alone. How do we get x alone? So we add the 2 to both sides.
I started like that.
So 2x is 9. Last step. Divide by 2. X equals, I just get a decimal. I think it's easier, 4.5. Okay, so that's step 1. Now, what do we do in step 2? What does step 2 say? Denominator alone equals whatever the right side says. No. Equals 0, huh? So denominator alone equals 0. It's an easy mistake to make because we've been, it's just you want to grab that number on the right, but don't. You grab the denominator alone equal to 0. It's got to be 0. We're wondering what makes the bottom 0, because what makes the bottom fraction 0 is undefined. Anyway, I won't go any further. Move that over. X is 1. So that's my other answer. So I got those 2 answers that I'm going to take to step 3 on the number line. So here we go in step 3. So number line. What 2 numbers go on the number line? So I encourage you to select -2, -1, 0, 1, 2, 3, 4, 5. So where are my cuts in the number line? +1 and 4.5. Good. And where am I going to check? X equals 0. Where is 0? I saw a lot of mistakes. People would write the check out perfectly, but then forget what section that came from. See how, bless you. See how I put a dot so I know what section I'm checking? And I do my work in that section. Really easy mistake to make. There are things you can do that will keep you from making that mistake. Like what I'm doing, putting a dot in the section and writing my work in that section. Notice I didn't write the work here or there because I'm checking the left section. It so happens. 0 is in the left section. So check X was 0. Where do we check? Whenever we check anything in math, where do we check?
The first equation.
We're checking the original, aren't we? Oops. Less than 2. So plug in that 0, and it goes right there, doesn't it? So we have 7 over 0 minus 1 less than 2. So that's 7 over minus 1 is less than 2. What's 7 divided by minus 1? It's minus 7, right? Right? If there were 2 negatives there, it'd be positive, huh? But 1 negative is just negative, isn't it? And anything divided by 1 is just itself. 7 over 1 is just 7. And the fact that it's -1 makes it -1. Now, is that true or is that false? -7 is less than 2. That's true. That means this is true, false, true. So the truth is found in
99.9.
this section and this section. All right, so you know how to say that, right? That's going to be, I just don't have any room to write it anywhere. That's going to be, let me do it up here. It's going to be negative infinity to 1. All parentheses. Now, there's no bracket here, right? So it's all parentheses. United with, now, how do you, 4.5 to infinity, but they don't want you to write, I think they want you to go back to the fraction. 9 halves. That's the same as 4.5. There's our answer. Does that make sense on that? Those two sections are shaded?
Oh, we have to just get back to the shade.
Is that good? Have I lost you? How are we doing? We good there? We have time for one or two more? We good there?
I couldn't cross multiply that.
Couldn't cross multiply what?
Oh, because I got the -2 right here. 7 equals less.
Oh, here, let me get it started.
It's 3. And then if you put them together, you cancel x, so it's no answer.
Right. Step 1. So step 1 is always change to equals, right? So x plus 3 over x plus 2 equals. I changed to equals, right? And then what do we always do? Put it over 1, diagonal, diagonal. Cross multiply. So we get 1 times x plus 3 is 1 times x minus 2. Good to there? Diagonal, diagonal. Distribute, distribute. X plus 3, x minus 2. So x they don't want to be alone. So you subtract x from both sides, and all of a sudden, there's no x at all. No answer. So there's no answer. So that's crazy. When x vanishes like that, there's no answer out of step 1. Go right on to step 2. Don't worry about it. Everything's going to work out fine. Keep right on moving. Step number 2. So what do we do in step 2? Denominator alone equals 0. Right? Just the denominator, just 0, not the number on the right side, huh? And that's just x. So that's my only answer when I go to step 3 on the number line. 2.
So the center is 2.
So we're gonna check where is 0, left side or right side. Yeah, 0's over here, isn't it? So check. See how I show my work on the side I'm on. Check x equals 0. I should probably make that line bigger at 2. There we go. Let's make a big, clear separation. Check x equals 0. Where do we check? Always the first step.
Minus infinity.
Grab the 0, put in the 0.
That side is the same.
Bless you. 0 plus 3, 0 minus 2 less than 1. Use your calculator. That's 3 over negative 2 less than 1. That's negative 1.5 is less than 1. Is that true or is that false? True. Well, we're just always getting true today when we check, aren't we? Have we ever got false? So that's true. So the left section is true. How do you say that left section? Negative infinity up to 2. All there's no brackets here. There's no bar from the beginning. Oh, I haven't done any bar one, have I? We good there? That making sense? Okay, step 1. What is step 1? Yeah. Step 1, change to equals. And solve. How do I solve that? What do you do when you guys are x squared pros, right? We had that a week or two ago. What do you do when you got x squared?
You do root 2 squared.
Get a 0. Get a 0 first off, right? Whenever x squared rears his ugly head, get a 0. So jump this to the other side. Becomes x squared plus 4x equals 0. And then we need to factor that. How do we factor that? Yeah. This is not a 2 parenthesis factoring, is it? It's just take out x. Like that. Then where do we go from there? Each one gets its own 0. Right? Because if two things multiply to equal 0, either one could be 0. This one's done. The other one, jump it over, -4. So we got two answers, 0 and -4. Zero and -4. We good? Is that good? There? And then I'm going to go ... The rest is the same. Put them on the number line, blah, 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 blah. Is that good on that one? Just want to make sure you saw the beginning of that thing. Questions on that one? Okay. About factoring. So we got 4 terms here. Our first step is to take that and set it equal to 0. Equals, right? Step 1 equals. And then you got to factor. That's hard factoring. First two, last two. What do the first two have in common? 16x squared. Take it out. What does that leave? X plus 3. Last two, what do they have in common? Minus 25. Take it out. What does that leave? X plus 3. What do you do when you have the same thing twice? Remove it. X plus 3. Remove it. Remove it. Start a new set of parentheses. X squared minus 25. It's the hard factoring one. See that? It's been a long time since we factored. That was back in chapter 6. Those were some of the hard factors. So when you have 4 terms in your factoring, you do 2-2 split. First two, last two. Take out what's in common. And then see how they have the same common piece? So I put it in the front, removed it, brought down the leftovers. 16x squared minus 25. There's one more step. It's a double-double. 4x minus 5, 4x plus 5 equals 0. Now it's finally factored. Then you set each one of those to 0, right? Because if a bunch of things are 3 things are multiplying to equal 0, each one could be 0. So the first one is 0. The second one is 0. Or the third one is 0. So then jump this one over. So x is -3. To the middle, jump this one over. 4x is 5. Getting a little sloppy there. 4x is 5. Divide by that 4. Jump the 5 over. 4x is -5. Divide by the... What is going on here? Divide by the 4. Boom. There's our 3 answers. -3, 5/4, and -5/4. I'll go ... Put them on the number line. Check it. I want to set up one more for you. Time is running here. So that's tricky factoring. Very good there. So then I'll go ... I would change those to decimals. This is 1.25. This is -1.25. You divide 5 by 4 in your calculator. Be easier for the number line work. 12x plus 7 over x minus 7x plus 2. Oops. Greater than or equal to 0. Okay, the reason I want to show this one because it has the equals. This is the one where we'll finally have to worry about step number 4. All right, what's step number 1 though? Change to equals. Change to equals. And do what? How do you solve that? The fraction on one side, whole number on the other. What do we always do? Put over 1, diagonal, diagonal. Cross multiply, right? So 1 times x plus 7 equals 0 times x minus 7, x plus 2. We okay with that? I just went diagonal, diagonal. We've done that a lot of times, right? Okay, I'm glad you helped though. I don't mean to say that you got it. I already know it. But is that good? Does that make sense? Diagonal, diagonal. Like that. And now, on the left side, that 1x is going to go through there. What's that? X squared plus 7x. What's the right side?
0.
0 times anything is 0. That's all just a big 0. Really, it would have been easier if I would have just left the left side as it was. Let me go back to the way it was. Because now, how do you solve that?
Give x to 0.
Yeah, two things are timesing to be 0. Each one gets their own 0. X is 0 or x plus 7 is 0. Jump this one over. Negative 7. So we got two answers out of step 1. Now we're off to step 2. What do we do in step 2, says the instructions? Denominator alone. Denominator alone equals 0. So grab just the denominator, nothing else. X minus 7, x plus 2. Equal to 0. And so that means the x minus 7 is 0 or the x plus 2 is 0. So you're going to get x equals positive 7 or negative 2. We got 2 more answers out of step 2. So we got 4 answers all together. 2 from step 1, 2 from step 2. They're all going to go on the number line. Minus 7, minus 2, 0, 7. I'm running out of time. I'm out of time. So I'm just going to do this really quick. So we have a whole bunch of regions. I can't check 0. Notice one of the lines goes right through 0. That's right. That's the other thing I didn't show you. What if one of the lines goes right through 0? You can't check 0. You got to check between lines. You can't check something that's right on a line. So, well, if I can't use 0, why was I using 0? Because it was the easiest number in the world. Well, what's the second easiest number in the world? 1. Just do 1. Or any number you want. So I'm going to do 1. Where's 1? Always show where it is. Right here. I'm going to check x equals 1. Check where? Original. 1, 1. I'm going to do it quick. I'm just putting 1 in everywhere in the original up there. What do you get? 1 times 8 over minus 6 times 3. Is that greater than or equal to 0? That's a negative number. All I've got to see is there's 1. If there were 2 negatives, it'd be positive. There's 1 negative. It's some kind of negative number. Is that greater than or equal to 0? No, it's negative. There we go. There's a false region. Many firsts in this problem. First time we couldn't check 0. First time we got a false. So that's a false region. A negative number is not greater than 0. Whatever that negative number is. So that's false. That means this is true. True. False. True. True, false, true, false, true. All right, finally. Let's give the final answer here. I'm going to go to a fresh screen really quick. Negative 7, negative 207. Negative 207. So true, false, true, false, true. So here's the truth. Here's the truth. Here's the truth. Right? 3 true sections. And we do have a bar. So we want brackets next to the numbers, not next to the infinities, huh? So how do you say this region? Negative infinity to negative 7. Oh, bracket. Bracket. United with. How do you say this section? Negative 2 to 0. Bracket. And bracket. United with bracket 7 to infinity. But having done all that, there is one exception to the bracket rule. And that's the step 4 I've written for you and never used up to now. It says, not by any denominator 0 answer, thank you, no way. Remember, because the bottom of a fraction can never be 0. That's the big no-no. That's the cardinal no-no in the math world. You can't make the bottom of fraction 0. That's undefined. If you try it on your calculator, anything divided by 0 would be air. You can't. So any number that would make the bottom 0 can't be an answer. It's craziness. So what numbers would make the bottom 0? Well, whatever answers you got out of step 2. Because that's the step where we said, hey, bottom, you're 0. Which was 7 and negative 2. Right? You can tell 7 minus 7 would be 0, and negative 2 plus 2 would be 0. 7 or negative 2 are not allowed under any circumstances to be answers, because they make the bottom 0. You can never equal 7 right on the money or negative 2 right on the money, because they can't be answers. So right by, what was it again? 7 and negative 2. So this one, nope, change him to parenthesis. And negative 2, nope, change him to parenthesis. Everybody else stays brackets, done. You cannot have a bracket next to those guys, because you can't be right on those guys. So honestly, I'm not going to give you one on the exam that has step 4 in it. All right, so this section and the next is due. Look at the syllabus. Both those.